Welcome back to Nature of Code in Rust and GGEZ. We're moving on to exercise I.4. Consider a simulation of paint splatter drawn as a collection of colored dots. Most of the paint clusters around a central location, but some dots do splatter out towards the edges. Can you use a normal distribution of random numbers to generate the locations of the dots? Can you also use a normal distribution of random numbers to generate a color palette? So I'm not sure about the color palette thing. I don't know if that means we want to basically make the random numbers like also do colors, like randomly colored dots, or if we want to actually make a real palette of there's a little bit of blue here, there's a little bit of red there. It sort of feels like it'd be um, more of changing the colors around. I think I'm gonna be tackling the first part of this and kind of maybe ignoring the second part. We can maybe play with some random colors afterwards, just sort of see what it ends up looking like. But I am interested in this cluster, like the splatter of paint. So I've already set up our VS Code here. I've named it exercise I.4. So we're going to want to bring in those two crates again. So let's go to our cargo.toml. I'm going to add in rand. And what was it called? Rand dister. All right. Let's go ahead and head on over to our library and sort of see what we want to do with this. I think we're going to sort of follow the same pattern as before. I want to remove our background color. They're going to be creating. And now we're free to sort of set ourselves up for success here. We can do just sort of I'm thinking maybe like a gray dot to begin with, and then we can maybe make it a random color later. Just to make that a little bit easier, we can sort of set ourselves up with a color. This can be a type color. We're gonna want our X, so F32, and a Y of where to put this, which is an F32. We're gonna want to have our circle, which is a mesh, and we're gonna have our random number. So our random, our normal RNG, which is a type normal of F32, and also going to want a just RNG, which is a thread RNG. I'm not sure if we need anything else right now, but obviously it's very easy to add these in later. So let's start with that color. This get sort of a gray. I'm thinking something near like decently bright. So maybe something like 200s all around. Oh, and it needs to be between 0 and 1. So maybe like 0.8. And then we'll make it fully opaque. All right, so that gives us our color. Then our X, where we're going to want to put these. I'm going to start X and Y at 0, and then we're going to update them to be that random number. Our circle. Bring in the mint 0.2. Again, I'm going to make this 0.0. I'm going to use the destination method on draw to sort of put it in the right place. Let's make this a 1.0 radius with a tolerance of 0.1. And then we're going to set our color. I'm thinking we can set this color to be white. And that will allow us to sort of reset that with this, overwrite it with this other color here. All right, so that goes a circle. Okay, then the normal RNG. And then we have our mean and our standard deviation. So last time we remember, it was the center was what our mean was. And I'm also thinking about like how I want to do this, like the X and the Y. Like, do I want a normal range for the X and another normal range for the Y? I'm not really sure because we could easily have like two of them set up for us. Let's try one for right now. And if we head back over to main, we have 1920 by 1080. We can set, like if we want exactly in the middle, let's actually make this a perfect square. And this is gonna make it a lot easier. So if we set you to be, let's say 1000 by 1000. Then in our main library, we're going to set you as 500.0. And our deviation, like how far out do we want it to go for a normal shape? Maybe something like 250. All right, so that gives us our normal range. G. And store it all away. All right, so in our update, what are we going to want to do? We're going to want to set our X and our Y to the next sample here. So let self.x is now going to be self.the normal range, sample, and pass it in a mutable reference to self.rng. We're going to do exactly the same thing for the Y. And I think that's enough for us for here. So then in draw, we're gonna draw a like the circle exactly where this this dot is. We're gonna overwrite the color and the location. And we can then set up, we can overwrite the color by just saying self.color here. It wants to take ownership of it. What's going to happen is it's going to copy out because color does implement clone and copy. So if we run this, let's sort of see what it ends up looking like. That was a lot of code before we even tried running this. So it's slowly filling in. Now I can see it. It sort of looks like stars showing up all over the screen. Perhaps this was too big of a deviation. They're all the way up into the edge. And this might need to run for a really long time before we actually see everything sort of like splotching up together. let's change some of these numbers a little bit. So I like the middle of the screen, but maybe let's try more like 50.0 normal. We could increase the size of our circle. I don't know how necessary that is. I'm pretty sure that like once all these circles like fill in all the space, then it's gonna look like paint spilled, and there's gonna be no gaps between them, which will be really, really cool. But that might actually, like, even with this, it might take a long time before it looks exactly like that. That being said, it still does actually look pretty cool. Let's try, just for speed's sake, increasing our radius to something like 5. Oh wow, it doesn't like having all these circles sort of like it really wants to be able to clear these, doesn't it? To clear the screen. And we're getting that weird, yeah, that doesn't look good as whatever that is happening. That doesn't look good. Maybe I can make you like a 2 radius and you'll not look terrible. Still not great. It's a little bit less flickering, but still quite a bit of flickering. Now, one way that I can get away with no flickering whatsoever is we could have a vector of these locations. So let's say we didn't have this X and Y here. Let's say we had like locations is going to be a vec of a tuple. And actually, you know what we can do? We can make those mint2 points. So this can be a point 2 F32. Then down here, we have this X and Y. I can just easily create a new locations. Oh, we don't even need this XY right now. We can get rid of that. Locations is going to be an empty vector. We're going to use the vec macro for that. And then you're going to be replaced with locations. All right. Then we're going to come down here for update. Instead of this self X and self Y, what we can do is create the point. And we're going to see X is going to be this. Y is going to be this. And we're going to do, let's see, that point equals, okay, so we get ourselves a point here, and then we're going to do a self dot locations push point. All right, so we're going to get just an infinitely growing vector for this. We'll see how many we can get before it potentially overloads and crashes and runs out of memory. We're gonna be getting lots and lots and lots of the frames, so we'll see how well it works. Now for this graphics draw, we want to actually loop through all of the locations and then draw based upon this destination. So let's just sort of reset this a little bit. We can also do our clear again. So graphics clear. All right, so we're gonna do a loop through. So for location in a reference to self dot locations, that gives us a reference to the point. Then we can do a graphics draw. a reference to the mesh, and then our drop param. So we're going to get our destination, which is going to be this location. I don't know if it needs to be cloned or copied. I think it does need to be. So I can just dereference it, and it should clone or copy it directly. And then we have our destination. We can also set our color to be self.color. And question mark, semicolon that. We should be good to go. Let's see if this makes any difference. Makes it look a little bit better. Oh yeah, that's so much better. I should be doing this instead of trying to like just not clear the screen every single time. Let's go back to a 5.0 circle size. That'll make it a little bit faster. It might be really interesting to run with the 1.0 across the entire screen and maybe like leave it running all night. Or at least until it crashes, have it like auto take some screenshots every 10 minutes or so, see what it ends up looking like. But this is pretty cool so far. We're able to get all of our, I can almost see that this will look like a paint splashy. We can still see like the very the definitions of the circles. I think that's because I'm doing a radius of 5. If I did switch that to a radius of 1 and I left it running for a really long time, I think that'll look a lot better. I'm not going to worry about it too much for this case. Now, let's say I wanted to do something with colors. I wanted to create like maybe a random color with a variation, like maybe close to like the mid range. Let's go ahead and we'll leave this as radius 5. Now our color is set here as this like sort of grayish color, but in update we're gonna have to have a normal RNG. This is for the, let's replace you. This is gonna be the like the location RNG, and I want to create a color RNG. Okay, so our mean, I want that to be something like 200.0 and a deviation of maybe something like 10, maybe like 20. Then we're going to save that away. First of all, you're not normal RNG anymore. You're a location RNG. You're going to be a color RNG. Normal, and oh, you know what I want this to be? I don't want it to be an F32. I want this to be a U8. Because I'm going to use that other new color, the other way to generate colors. So you're going to be just 220, and we're going to throw color RNG. Then down here in updates, so we have update the self locations. We can now do a self dot color is going to be equal to the color RNG to sample. Okay. What are you upset about? The trait bound U8 random distribution numbers float is not satisfied. Oh, so it has to be a float of some kind. Oh, like an F32 or an F64. So let's go ahead and actually set you to an F32. you will have to be dot 0 and dot 0. And then what we can do, we'll, in update here, we can't do color just quite like this. Do a color from RGB. And then for each of these R, G, and B, we're going to do a self dot color RNG sample, pass it in a mutable reference to self dot RNG. And then we're going to as a U8. So downcast it down. There might be some lossiness there, but hopefully not too much because we're trying to limit it to within the U8 number space. And then we're still going to use self-dot color. Let's take a look at what these colors end up looking like. Oh, the big thing here is that they're all changing colors. We're not seeing the separate ones. Like everything's changing color, which is why we get that sort of flashiness, which is not ideal. So we actually want, if we have locations, we should also have colors. It's going to be a vec color. Colors is equal to an empty vector. And we'll throw you in here too. Then we're going to create, instead of this self-dot color, we're not going to need that anymore. So you can go away. You can go away. You can go away. Okay, so I'm going to say let color equal to this, and then self.colors.push colors. So that way, every time we create a location, we're also going to push in a color. And then we're going to need to know which one to do. So instead of this like for in, we can do a self.locations, get an iterator from this. We don't need this reference. That will give us now this point. And then I'm also going to enumerate, which will give us the index. So we'll have index and then the location. And so then here we'll do self.colors of position index. And that should do it. Let's go ahead and give this a shot. Now each dot is going to be a completely separate color. It's going to be moving around, it's going to be placed sort of like in this 2D space, the X and Y, based upon this normal distribution. We can also update, let's say we have a mean of like the exact center, and we have a standard deviation of, let's go close to the edge, like 400. So it should be spread all around. That might be a little bit too much. Let's try like 250. So most of them should be clustered towards the center with a few out near the edges. And if we let this run long enough, a lot of the dots in the center would sort of be filled in. And we can play with those numbers to sort of make our art look exactly how we want. Size, circle size wise, the distribution wise, or anything else really. Anyways, I'm going to call it done for exercise I.4. I think this is sort of good enough of playing with the normalized random number distribution. Anyways, I'll see you in the next video. Have a great day, and bye.